Hello, my name is Christopher Fadanelli, and today I'm going to be going over sensors that are made for a double lane change. Sensors are attached to the outermost tire on each axle, and during the event, if any of the tires exceed the boundaries shown on the screen, so this brick wall, simulation will automatically end. Let's go over the sections defined in the double lane change. We have section 1, which is the first initial straight before the car will start to maneuver to the second lane. The length for section 1 is going to be a constant that we can define. The overall section 2 length is the wheelbase of the vehicle, as well as a defined linear straight, as well as we can define the lateral offset from the vehicle move from the first lane to the second lane. Then we have section 3. How long the vehicle is going to be in the second lane. Then we have section 4, which the lateral offset is going to mimic the same one from section 2, and the overall length is the same as section 2, the wheelbase plus defined length. And section 5, just like section 1, it's how long the vehicle is going to be in the first lane until simulation ends. Now I'm going to show you how to incorporate these sensors into your model. I have my vehicle model already set up, and I already introduced a double lane change. As you can see, I have my parameters here. Now what I need to do is import the sensors into my model. So I'm going to go to File, Import, Model Definition. I'm going to choose the definition file. I'm going to select it as the DLC sensors. And I'm going to have all of the labels and variables set to default. Say OK. And now we have the system loaded in. Now let's verify the attachments. So I'm going to go to the cone system, and at the attachments we have two bodies. So this is going to be the first outermost wheel on your first axle. This is going to be the outermost wheel on your last axle. So I'm just going to verify that they are correct. All right, so this is set to the front wheel of the auto tires. That's okay. And for this last axle, this is the rear wheel of the auto tires. And so now let's dive in to the system. So we have a data set for setting up the cones. So what happens is it's automatically going to calculate the wheelbase as well as the track width. This is defined from the attachment wheels that we just defined. We can define the tire width. And then this is where we are going to implement our section lengths as well as our lateral offset. Just like before, the section 1 length, this is the section 2 length without the wheelbase added. Section 3 length, same thing for section 4, the predefined length without the wheelbase added, and section 5. And if you want to edit the width of section 1, 3, and 5, you can do that here. So let's say I'm going to do a width multiplier of 2. It's going to automatically change the width of section 1. I'm just going to revert back. And so now if we dive in a little bit deeper, as you can see, we have our two axles, axle 1 and axle 2. And in each of these systems, there are sensors for each section, so section 1 through 5. And if we open up these even more, you can see there's a sensor for the left and right tire for each section. These sensors will be active when the vehicle is present within that section. And so these are already set up for a 2-axle vehicle. I'll show later on how to incorporate another axle into the sensors. For right now, let's just verify that the double lane change works. So let's go to our double lane change event. And let's have our velocity set for 15 miles an hour. And now let's run our event. All right, so the analysis has been complete. If we run the animation, we can see that the vehicle did not cross the boundaries, as well as the simulation did not end early. So let's add a little bit more extreme speed. So let's change it to 50 miles an hour. And let's run the simulation one more time. All right, analysis complete. We can see that the vehicle is going to come in contact with the walls in section 3. So as you can see, the rear outermost tire on the right has come in contact with the boundary. So simulation has ended early. This is how to determine if simulation ended early in animation. Now let's go over how to determine that through Hypergraph. Okay, with Hypergraph loaded up, I'm going to change my type to event sensor, and I'm going to select all of the requests that have left and right tire, as well as I'm going to have the component set to sensor. I'm going to plot it. With results loaded in, we can see that one, the sensor was engaged. So if we hover over that line, we can see that the rear right tire on the last axle exceeded section 3. This is how we can determine if the simulation failed through results from Hypergraph and looking at the animation. Now let's go over how to incorporate when you have more than 2 axles in your vehicle. Alright, so this model, it is a pickup truck with 3 axles. So I already have the outermost tire on the first axle defined, and the outermost tire on the last axle defined for the attachments. We need to incorporate another system with sensors to incorporate the third axle. What we need to do is export one of the systems. So I'm going to do axle 2. I'm going to right click and say export. I'm going to make sure the system is correct and everything's set to default. I'm going to select where I want to export it. All right, I have my spot. I'm just going to call it axle, and I'm going to export it. Now what I need to do is I need to re-import that system back in. So I'm going to go to the cone system. I'm going to do import. I want to select the definition file, choose the axle, and I'm going to rechange the label from axle 2 to 3. I'm going to say OK. Now we have our third axle. Let me first change the attachments of the second axle because by default it is choosing the last axle. So let me do that right now. So I'm going to go to rear dual, go to the first axle and change it. Change the wheel. Okay, and now for the third one, I'm just going to verify it is the outermost tire. All right, so it is. That's good to go. Now what needs to be done is for all these sensors have to be renamed. To rename the sensors, all we have to do is go to the entity editor and change the label. So I'm just going to do 3. And you're going to need to do that for all the sensors for each section. Just change to the correct axle. This is to make sure that all the outputs for all the sensors will be recorded. This was a demo on how to set up the sensors for a double lane change. Thank you and have a good day.